Example 4. Find the radius of convergence and interval of convergence of the series. The sum from n equals 0 to infinity of open -3 closed to the power n times x to the power n over the square root of n plus 1. Solution: let a sub n equal open -3 closed to the power n over times x to the power n over the square root of n plus 1. Restarting the solution, let a sub n equal open -3 closed to the power n times x to the power n over the square root of n plus 1. Then the absolute value of a sub n plus 1 over a sub n equals the absolute value of open -3 closed to the power n plus 1 times x to the power n plus 1 over the square root of n plus 2 times the square root of n plus 1 over open -3 closed to the power n times x to the power n equals the absolute value of 3x times the square root of n plus 1 over n plus 2 equals 3 times the square root of 1 plus open 1 over n close over 1 plus open 2 over n close times the absolute value of x approaches 3 times the absolute value of x as n approaches infinity. By the ratio test, the given series converges if 3 times the absolute value of x is less than 1 and diverges if 3 times the absolute value of x is greater than 1. Thus, it converges if the absolute value of x is less than 1/3 and diverges if the absolute value of x is greater than 1/3. This means that the radius of convergence is 1/3. We know the series converges in the interval open -1/3 and 1/3 close, but we must now test for convergence at the endpoints of this interval. If x equals -1/3, the series becomes the sum from n equals 0 to infinity of open -3 closed to the power n open -1/3 closed to the power n over the square root of n plus 1 equals the sum from n equals 0 to infinity of 1 over the square root of n plus 1 equals 1 over the square root of 1 plus 1 over the square root of 2 plus 1 over the square root of 3 plus 1 over the square root of 4 and so forth, which diverges. Use the integral test or simply observe that it is a p-series with p equals 1/2 less than 1. If x equals 1/3, the series, the sum from n equals 0 to infinity of open -3 closed to the power n open 1/3 closed to the power n over the square root of n plus 1 equals the sum of n equals 0 to infinity of open -1 closed to the power n over the square root of n plus 1, which converges by the alternating series test. Therefore, the given power series converges when -3 is less than x and x is less than or equal to 1/3. Let me restart that sentence. Therefore, the given power series converges when -1/3 is less than x and x is less than or equal to 1/3. So the interval of convergence is open minus 1/3 and 1/3, close bracket.